So when we look at a Claisen reaction is between esters. It works the same way as aldols, but you have esters, okay, in the process. And the esters, your product will be a little bit different. It's not going to be an alcohol. It's actually going to be a keto ester, okay? But the process is pretty much the same. So which means that let's go ahead and write out our ethyl ethanoate, which is this. So ethyl ethanoate, and then when we do the Claisen reaction, you still need a base. So here it is sodium methoxide. So that's the base. And again, you can use any base that you want, strong one. Sodium methoxide, ethoxide, sodium hydroxide, LDA, any of those ones that would pick up the alpha proton. Okay, now remember, you cannot do this reaction with acids. You do this only with esters, okay, for very obvious reasons. All right, so then you have OET. And now that you have the nucleophile ready, where is my electrophile? So just like in aldol, when we were able to use different aldehydes or ketones, here also you can use different esters. But here, since I've been given ethyl ethanoate only, that's what I'm going to go ahead and use. I will not use anything else. So we'll go ahead and take another one of those. And this is the electrophile right here, right? That's the electrophilic carbon. So my next step then is to form my carbon-carbon bond. And as you know me from before, saying all the time that you need to make sure that your bonds are correct. We'll worry about looking pretty later on. Okay, so this carbon, this carbon, this carbon, and that carbon, okay, is joining. So here I will have an ester as well. And so the next step is where the difference is between aldol and Claisen, because in Claisen you end up forming a keto ester. So where is the keto ester coming from? The keto ester is coming from the fact that you end up getting a ketone here, and this OET leaves, and it leaves, of course, as an ethoxide. Okay, and it's because you're working in such a strong basic environment, it's able to leave. Okay, so you have methoxide already, so now you're also letting go of ethoxide in there. So what's our product then? So we have that we form the ketone over here, then we have 1, 2, and then the ester, okay, that we have. So this is a beta keto ester, and that's what we usually form when we do Claisen reactions. Now if you want this to look pretty, sure, let's do that. So 4 carbons, okay, and then on the first one we have the ester, and then on the third one we have the keto. Okay, so alpha, beta keto ester. That's what you end up getting. These are really neat reactions because just like in aldol you formed an alcohol and an aldehyde or a ketone, here you form a ketone, okay, along with an ester. The ester is already there, but you know, now you also have a ketone, and you ended up joining 2 fragments together. So forming a carbon-carbon bond is really the most interesting thing in organic chemistry. Well, one of the most interesting things. Okay, so that's Claisen reaction.